This is lesson 7-1A. We're going to be finding the area of a parallelogram and a rhombus. When we talk about parallelograms and rhombuses, their shapes are very similar, but the difference is that a rhombus, which is very similar to a diamond, has 4 equal sides. So in a rhombus, all 4 sides are equal, and there's 2 sets of parallel sides. So the top and the bottom are parallel, the left and the right are parallel, and all 4 sides are equal. They're the same length. But when you look at a parallelogram does not have 4 equal sides. So with a parallelogram, the top and the bottom would be the same length, and the left and the right would be the same length, but they are not all the same length like in a rhombus. So when we find the area of a parallelogram and of a rhombus, we use the formula that we use for finding the area of a rectangle or of a square. And that formula is area equals base times height. So you have to remember that. Area equals base times height. And let's look at why we can use that formula with parallelograms and rhombuses. And if we look at example 1, it says, look at the parallelogram below. If you move the triangle to the opposite side, you form a rectangle with the same area as the parallelogram. So all they're doing is they're taking, in this first shape on the left, they're taking that triangle that I'm coloring green right now, and they're moving it to the right side. So now they have a triangle forming a rectangle with that shape. So that proves to us why we can use the area equals base times height formula to find the area of a parallelogram and of a rhombus. Another important thing for us to notice is that the height of the parallelogram, h, is going to be perpendicular to the base. So what perpendicular means is that it forms a 90-degree angle. So if I'm going to make this picture bigger, if we have a parallelogram here, here's my parallelogram, my base, the base is going to be what it's always like standing on. It's the bottom. The base is the bottom. But now I have to look for the height. So when you go to the doctor's office and the doctor asks you to stand by the measuring tape so that they can get your height, you have to stand tall. You stand straight up and down. So this dotted line that I just made is the height. It forms a perpendicular line, a 90-degree angle with the base. And that's what that square box that I just drew represents. It represents that the height forms a 90-degree angle, a perpendicular line with the base. Now, let's say we had a number here. I'm just going to write S. We could pretend that that side length is any number. Well, if that's S, this is also going to be S. We are not using that side length to find the area because it's not the base and it's not the height. The height is always going to be standing straight up and down. So you have to be able to identify the base and the height when you're looking at these shapes to help you to find the area. And sometimes when you talk about a rectangle, we talk about the length and the width. Well, with parallelograms and with rhombuses, you're always going to talk about a base and a height. But we still are multiplying those 2 lengths. So let's start by looking at a problem here. We have a parallelogram, right? So we have to figure out, what's the base and what's the height? So I'm going to start by rewriting my formula, and you should be doing this in your notebook also. Area equals base times height. When we have 2 letters next to each other or a number and a letter next to each other, we should know that that means multiplication. So now I'm looking at my parallelogram here. I have to figure out which is the base. Do I know which one the base is? Yes, I do. The base is going to be the 7 centimeters there. So I can plug that in. Okay, well, the base is 7 centimeters. 4.5, do I know what 4.5 is? Is 4.5 the area or the height? 4.5 is going to be our height. So we're going to have 7 times 4.5. Make sure you know the difference between your multiplication dot and your decimal. And when I multiply that, it's going to find the area. And that makes sense because my question is saying to me, find the area. So area is going to equal, well, the base times the height. We should be plugging it into our calculator. 7 times 4.5 is 31.5. 31.5 what? It's going to be 31.5 squared centimeters or centimeters. So we can say centimeters squared, which is the same thing as maybe you've written in the past, squared centimeters. But we're just going to write centimeters squared. Centimeters squared. Anytime with area, the units are going to be squared. Now let's look at the second example. Find the area of the rhombus. The pendant at the right is in the shape of a rhombus. A rhombus is a parallelogram with sides of equal length. What is the area of the pendant? Okay, so again, we're going to start with our area formula. Area equals base times height. Now we have to look and see, well, what information do we know? What can we plug in? Okay, so let's also look at some of the information they gave us here. It says the tick marks indicate that the sides have the same length, and that's how they know that it's a rhombus. Each of these tick marks, that's the same length as the bottom, which means if they all have one tick mark, that means they're all the same length. If there were 2 tick marks on the top and the bottom, then that would mean that the top and the bottom are the same length, and it's a different length than the left and the right. But in this case, those tick marks are telling us that all 3 sides are the same. That doesn't mean that the base and the height are going to be the same. And that's why we have to look at this picture very carefully. So let's see, do we know the area? No, that's what we're finding out. We're finding out what is the area. So we're going to say, okay, area equals, what does the area equal? What's the base? What number can I plug in for the base? I will plug in 3.8, 3.8 centimeters. I'm just getting rid of the centimeters for right now so that my work isn't too messy. Times the height. Well, what's the height here? The height is 3. So my area is going to equal 3.8 times 3. Again, plug it in your calculator. What's the area? The area is 11.4 centimeters squared. Okay, let's look at this. Try it. Question A. Find the area of the rhombus. So what is the area formula? Area equals base times height. Now, today we're finding the area. So I know that the area is going to stay as A. In tomorrow's lesson, we're going to know the area and either be finding the base or the height. So it's going to change it up a little bit tomorrow. But for today, we're finding the area. So now we plug in. What's the base? What's the height? Okay, so 22.5 millimeters. Is that the base or is that the height? That is the base. So we would have A equals 22.5 times the height here. Notice how the height is forming a perpendicular. The height is perpendicular to the base here with those dotted lines at 90-degree angle. So we say 22.5 times 20. So what is the area? What does the area equal? 22.5 times 20 is 450. Now let's figure out what our units are. Go back to the question. Is it centimeters squared again? No, it's not, because we have mm. So if you think back to our conversions unit, mm is millimeters squared. So the answer is 450 millimeters squared. And you should have all of that work shown every time we do your Homework questions, every time you're doing these questions in the classroom, I want to see each of these steps, that you're writing the area formula, that you're plugging in the numbers, and that you're then solving it. And your answer should have the units.